So y'all, so like I said, we're doing our Module 4 review. All right, so number one, they want to let f of x equal x minus 1 and g of x is going to equal x squared plus 2. On this problem, they want me to find f compose g of a positive 7. So this is out of 9.1 doing the composition of functions. So this f composed g of 7, remember, that's just like f of g of a 7. So what we're going to do, we're going to start with the g of 7 in here. We're going to find g of 7. Once we get that answer, we will plug that into the f equation, okay? So the first thing we're going to find, g of 7. Well, g of 7 will equal this g of x, putting a 7 in for the x. So y'all, that'll give me 7 squared plus 2. All right, so working that out, 7 squared to be 49. That's 7 times 7. And then that 49 plus 2 is going to give me 51. So now that g of 7 equaled 51, this 51 now, that's going to go into our f of x. So that since that's going into f of x, we will now be finding f of 51. So take the f equation, put a 51 in for the x. That's going to give me 51 minus 1. All right, so I just put my 51 in for the x now. And then 51 minus 1 gives me a final answer of 50. And that's what MATLAB, y'all, that's what it wants, is that final answer there, okay? All right, now number 2 and number 3 are doing the same thing, but they're not going to give me numbers for the replacement values, which means all we can do is do the operation and simplify, okay? Now for the next two, though, they want me to find the domains also. So what we're going to do, we're going to find f composed g of x, g composed f of x, and the domain of each. Okay, so this is like two problems in one. We're going to find f composed g, g composed f, and then those domains, okay? Now for me, they're giving me f of x equals x plus 17, and then my g of x is equal to a x minus 17. Y'all are going to be exactly the same other than the numbers, but it's going to be plus a number and then minus that same number. So I'm going to start with the f composed g of x. So that's going to be like this, f of g of x. So the first thing I'm going to do is g of x. So g of x was given to me, and g of x is x minus 17. Now notice, I cannot do nothing to that. They did not give me a number to plug into it. So since they didn't give me any numbers to plug in for the x on this one, I cannot do nothing to it. So this whole thing right here, the whole thing is going to go into f of x. Just like up here when I had the numbers, okay? So we're going to put the whole thing into our f of x. So that means we're finding f of x minus 17. So we will take our f equation, and in place of this x, I'm going to put x minus 17. So I'm going to have x minus 17, and then I still got a plus 17. So the question would be, can we simplify that at all?
Yeah, wouldn't the 17s just cancel out?
Yeah, those 17s are going to cancel. Good job. And since those cancel, our final answer will be just the x. And y'all, your numbers will cancel out just like mine. So we should all pretty much end up with x's on that one, okay? So that was F compose G. Now we'll do our G compose F of X. And once we do this one, then we'll start our domains for each of these, okay? So they have you find the F first, and then the G, and then the domains of each. So G compose F of X is like this, G of F of X. So I'm starting with the F of X this time. You always start with the innermost parentheses, right? So F of X is equal to X plus 17. Well, y'all, once again, they didn't give me no values for our X's on this, so I cannot do anything to that. So that means this whole thing here goes into the G of X. So that means I'm going to be finding G of X plus 17. All right, so here's my G equation. In place of that X, I'm putting that X plus 17. So that's going to give me a X plus 17. And y'all, then we still got the minus 17 at the end. And y'all, I guess the same thing's going to happen on this one, right? Over here, you had minus 17 plus 17. Well, on this one, I got plus 17 minus 17. So those are going to cancel. And y'all, once again, my final answer is X. So on number two, both of these should match because the functions are basically the same other than one's being added and one's being subtracted, okay? All right, so now let's start some domains. First, I'll do the domain of f of g, and then over here, I'll find the domain of the g of f, okay? Now, they want me to write the domain in interval notation, so that's using parentheses and negative infinity to positive infinity. My question is, do I need to kick out any numbers from my domain working these first functions? And if y'all remember, what's the only thing we're really worried about on a domain? And that's those fractions, right? And really the only thing we're worried about those is the denominator. Well, y'all, we don't see no fractions. So since I don't see no fractions in these functions here, that domain will be from negative infinity all the way to a positive infinity. Well, how about G compose f of x then? What y'all think that domain's going to be?
Want to be the same?
It's going to be the same. There you go. So basically, these both are going to be what we would technically call all real numbers, right? Okay, also, y'all's number two, it will really be pretty much like my number two, okay? Now, number three is going to be the same thing we're going to do, f of g, g of f, and all that. But I guarantee you, number three, they throwing the fractions at us, okay? So let's look at number three here. So I'm going to do the same thing, find f compose g of x, g compose f of x, and the domains of each. All right, so my f of x is going to be 2 divided by 1 minus 7x. And then my g of x is going to be 1 divided by x. Now, y'all, let me tell y'all about this problem. Everybody's g of x will be a 1 over x, just like mine. The differences are going to be our f of x's. And the only differences I've seen on the f of x's was you might not get a 2 on top, and you might not have a 7 in front of that x. But those are the only two numbers that I've seen be different on this, okay? So they're going to be really similar. So y'all, I'm going to start out doing f composed g of x. So once again, that's going to be this, f of g of x. I'll just write it like this so that y'all can see. I'm doing the g of x first because it's the innermost function, okay? So let's see, what is g of x? Well, g of x is 1 divided by x. So we're sort of at a point again where I cannot do anything to that because they didn't give me a number here. So y'all, guess what? That means this whole thing goes into f of x. So since this whole thing goes into f of x, we're going to be finding f of 1 divided by x. So I'm going to take this f function and replace that 1x with a 1 over x. So that's going to give me 2 divided by 1 minus 7 times 1 over x. All right, so the problem that we got on this one when we simplify it, we cannot have a fraction inside of a fraction. So we're going to have to simplify it so that we only have the one main fraction, okay? We cannot have a fraction in the denominator or numerator, okay? So y'all, the first step I'm going to do would be to multiply 7 times 1 over x. And to help me out, I always put a 1 under that so that I realize I'm just going to multiply straight across. So the top will stay 2 at this point. On the bottom, that'll become a 1 minus, and if you multiply straight across, 7 times 1 is 7 over 1 times x, which is x. All right, so I got one more step to get rid of this fraction now. Since I don't want this 7 over x to stay in fraction form, I'm going to get rid of that denominator by multiplying all 3 parts of this by that x. So on top, I'll have 2 times x. On bottom, I'll have the 1 times x minus my 7 over x times x. So all 3 parts got to be multiplied by the x. The reason is what you do to the bottom of a fraction, you got to do to the top, and then multiplication distributes over adding and subtracting. So y'all, why did I do that? What can I do right here? These x's are straight going to cancel out now. So these x's cancel out, so what's left? 2 times x on top is a 2x over 1 times x is x minus, well, these x's canceled, so all that's left is my 7. I now have a fraction with a numerator and a denominator, and that's as far as I can simplify it. So that is our final answer. Now here's what's fun. Y'all's answers are going to be really similar to that, okay? All right, so that was F compose G. So now I'm going to do G compose F of X. So doing it this way, it's like finding G of F of X. So y'all, that means on this one, I'm going to start with the F of X. So let's see, F of X is right here. It was 2 divided by 1 minus 7x. Well, we're at that point again where I can't do nothing to that. So y'all, since I can't do nothing to that, this whole thing goes into our G of X. So that means I'm going to be finding G of 2 divided by 1 minus 7x. All right, so here's my G function, 1 divided by x. So that's going to be 1 divided by, and y'all, my x is the 2 divided by 1 minus 7x. Now, this time I'm going to do this one. So I got a 1 on top being divided by this fraction. I don't like this fraction inside of my fraction, okay? So I'm going to do this one the same thing I did here. To get rid of this fraction, I multiplied by the x. Well, y'all, to get rid of this fraction here, I'm going to multiply by the 1 minus 7x. And I will do that to the top and the bottom, okay? So I'll have my 1 on top times 1 minus 7x. On bottom, I got my 2 over 1 minus 7x times 1 minus 7x. All right, look here. I crossed out this right here. Well, right here, these match. So I'm now going to cross them out. So let's see what's left. 1 times 1 minus 7x will be 1 minus 7x. And your only thing left on the bottom is a positive 2. All right, at that point, you cannot simplify any further. Now, y'all, you're going to notice your answers got to be really similar to mine if you're working this right, okay? Because like I said, all they're changing is a couple numbers on your f of x. All right, y'all, but watch these domains right here. What can this x not equal? And it's the same thing right here. What can that x not equal for that 1 over x?
A negative number?
Well, Brandon, remember, there's only one x down there.
Okay.
So that thing cannot equal what y'all got up here, Christina? 0, right? Since you only got the one variable down there, this x cannot equal 0 because that would make this thing undefined anywhere we got that single x. So right
Okay.
off the bat, we know that an x cannot equal 0. Now, what about when you got to this final part? What number can this x not equal right here? Good job, y'all. That's a 7, right? Because if you put a 7, 7 minus 7 would make that 0. So we got to exclude the 7 also. So I know for this one, x cannot equal 0 because of the 1 over x. And then x cannot equal 7 because of that x minus 7. So my domain will start at negative infinity. The first number I get to will be 0. So we're going to exclude 0 and union around it. From 0, we'll hit 7. We cannot equal 7, so we're going to union around that 7. And y'all, that's the only two numbers I'm kicking out, so this thing's going to head off towards infinity. All righty, so let's look on this one. So my first trouble spot looks like right here because I got a variable in that denominator. So that was a little trickier to figure out. So what you can do to that one, you could set 1 minus 7x equal to 0. And let's solve that for the x real quick. Once we solve that for the x, we'll have a number to kick out, okay? So y'all just going to subtract 1. Whoops. Subtract 1 from both sides. So I get my negative 7x equals negative 1. And then I'll divide both sides by negative 7. So that makes that an x. And then that's going to cancel, making that a positive 1/7. So at this moment, I know that my x cannot equal 1/7. All righty, y'all. Let me look here. So that's the only thing in the denominator here, right here. What about my final answer? Do I need to exclude any numbers out of that final answer? Oh, Carlitha, you on a roll today. There's not even a variable down here, is there? So y'all, since there's not a variable down here, you can't turn that 2 into a 0, can you? No, so since I cannot turn that 2 into a 0, the only number we got to exclude is that 1/7. So y'all, this domain will go negative infinity to our 1/7 union our 1/7 to a positive infinity. And I'll show you on this, they'll have A, B, C, D for you, okay? So there's our, what was our first one? 0/7. So here's our 0/7 we would have picked. And then this one was what? All we kicked out was a 1/7, okay? So they'll have answers on those for y'all to choose on that one with the A, B, C, Ds, okay? All right, y'all. So for number 4, I'm about to go to the math lab and pull up their graph, okay? Whoops. All righty, so I'm looking at this graph of this function they gave me. So my question is this graph 1-to-1? Now, if that graph is 1-to-1, it has to pass the horizontal line test. And y'all remember, the horizontal line test says that if a horizontal line can intersect that graph more than once, it is not 1-to-1. Y'all, I don't know, pretty much anywhere on that graph, if y'all draw a horizontal line across it, it will intersect it at least twice on that. So y'all, good job, Rebecca and Carlitha. That thing is definitely a no on being 1-to-1, okay? All right, y'all, so back to the paper. All right, so let's see. This will be number 5. All right, so this one wants me to determine if 1-to-1 if 1-to-1, find the inverse. So this would have been the 9.2 stuff, okay? So that my function is f of x equals x plus 2. Now, y'all, I'll give y'all a heads up on this. For number 5 and number 6, they're both doing this. They will both be 1-to-1. Okay? So if you mark that it's not 1-to-1, you will miss these questions. So we're going to find the inverse. So y'all, this is when to find the inverse. What did I change the f of x into? Do y'all remember? Well, I will say, Angela, the -1, I used that -1 when I did the F inverse notation with the F -1 of X. But I actually, when I solved it, what did I turn that F of X into? Which variable does the F of X sort of stand for? Oh, there we go, Carly. If you pulled it up, we got to change it into a Y. So Y is going to equal X plus 2. So do y'all remember now at this point, didn't I swap that X and Y around? So at this point, we're going to switch them so that we get X equals Y plus 2. Now, since I switched them, I'm now going to solve for the Y. Well, if I want to get that Y all by itself, this 2 that's being added, we're going to subtract from both sides. So we're going to come in and subtract 2 from both sides so that I get an X minus 2 equal to my Y. And then, y'all, the last step, I turn the Y into the F inverse of X notation. Now, MathLab will give you the F -1 of X. All you got to put in is the X minus 2. All right, y'all, so that's your trick on 5. 6 is the same thing. Determine if 1 to 1. If 1 to 1, find the inverse. Well, once again, number 6 is definitely going to be 1 to 1. So mine is f of x equals square root of x plus 3. Now, everything's up under that radical, okay? Alrighty, so we're going to solve this just like we did here. I'm going to turn the f of x into a y. Y'all, next step, what would y'all do next?
Flip the y and the x.
There you go. So we get an x equals a square root y plus 3. Now, we got to solve this for the y, but y'all remember this. We cannot subtract 3 while it's up under that square root. So since I need to get rid of this square root before I can do anything with the y or the 3, we're going to square it perfect. Square both sides. So that's going to stay at x squared. And y'all, when you square this exponent cancels that square root. They cancel each other out. So all that's left is the y plus 3. All right, y'all, so let's see. Our next step to solve for the y is to subtract 3 from both sides. So I get an x squared minus 3 equals my y. Now for this one, MathLab will give you the MathLab gives you A, B, C, D answer on this one. So F inverse of X is going to equal X squared minus 3. Now, y'all, here's the thing on this one. Since the inverse ended up as an X squared type function, remember X squared functions are parabolas. So you got a domain restriction on this one. And your X has to be greater than or equal to 0. All right, y'all. So y'all's number 6 is going to really be similar to mine, other than the 3. Okay. Y'all might have an x plus 5, x plus 4, something like that, okay? Um, but this will be an A, B, C, D answer, and you'll see this as one of your answers. All right, y'all. So number 7, we're going back to the math lab. So let me pull math lab up and go to number 7 here. So the question is, which one of these 4 graphs is the exponential graph for y equals 2 to the x? And you just got to remember what them exponential graphs look like. Now, y'all, I will tell y'all now, C would be logarithmic. But when we was doing those exponential graphs, which tool did we choose? Oh, Carlithia, you're on the right path. For the exponential graphs, you always choose the tool that looked like B. See y'all what it was this one, 2 to the x? So let me show y'all real quick. So go to y equals and punch that in. 2 exponent x. And let's hit graph. There you go. Y'all watch this. I'm going to show y'all a trick. I'm going to get 2 into a 5. I now have 5 to the x. Watch this graph. Oh, it looks almost the same, don't it? I don't care what your base is. If it's exponential like this, watch this. 10 to the x. Hit graph. Y'all, it's the same graph. It's going to come through and it goes uphill, okay? So, knowing that, we're choosing B on that one, okay? All right, y'all, I'm going to stay on Math Lab for the next one for 8. All right, let's click. All right, so let's see on this one. The first step, they're giving me f of x equals 2 to the x plus 3 minus 5. So we're starting with the graph of y equals. Right here, you're going to put in your base, which is the 2. So whatever that number is in front of the exponent is your base. Now let's see what that shift, it says shift it blank 3 units. That 3 is being subtracted from the x. I mean, that 3 is being added to the x, right? So since mine is being added to the x, when you add them, remember, you think they go right, but they actually go to the left. So y'all good right there. So that's going to be left 3. So if you're adding, it's left. If you're subtracting, it would be right when it's added or subtracted from the exponent. Now, this minus 5 at the end just is being subtracted from the whole function. So on this one, left, down, up, or right, if I subtract 5 from the end of my function. And y'all, that one actually does what I want. It will go down. Good job. All right, so once you put that in, you had to graph this doing those moves. So I'm going to click for my graph. We're going to click the exponential tool, second one on the second row. And you see it says selected exponential tool. Click on your graph anywhere. Now here's where you got to be careful. Y'all, the most important thing is to come down here in the very bottom left corner where it says base. You need to change that base from an E to match the base of your problem. So for me, my base was a 2. Then I'll come up here. I went left 3, so horizontal, I would move to negative 3. And then I went down 5, so vertical, I would go to negative 5. Put in all your moves and then save it. Okay. So see it move my graph left and down. All right, y'all. So now I'm going to go to my writing pad. All righty. So we are on number 9. Now, number 9 is about, y'all remember Melissa, the little girl? She got a CD. So we're doing Melissa again. So this time I got Melissa's 6th birthday. She gets a $5,000 CD that earns 5% interest. And it is compounded semi-annually. They want to know if it matures on her 16th birthday, how much money is available? All right, so back when we was doing the investment type problems, this come out of 9.3. We were using this formula where we said the amount in the account at any time t equaled P, which was her principal balance, times 1 plus R divided by N, where R was the interest rate, N was the number of compounds, and then that was raised to the N times T. So y'all, the first thing you got to figure out, what is T? How much time passed between the 6th birthday and the 16th? All right, what do we got? 10, good job. So our time is going to be 10 years. So we're going to find the amount at 10 years. Right, so P is my initial amount, which was my starting amount. Well, we got 5,000 for that. All right, then you got 1 plus. So y'all, here's my question. The interest rate is 5%, but what are y'all putting in my formula for that R? Oh, Ella, good job. That is a 0.05. Remember, y'all, take that 5%, move that decimal left twice, which means you had to add a 0, and that made a 0.05. Well, then how about this one, y'all? What is N if it's compounded semi-annually? How many times did we say, whoo, you're quick? Okay, so that is definitely a 2. So you're dividing by 2, and then that'll be 2 times my T, which was 10 years. All right, so we would punch this in, and they want us to round it to the nearest cent. So when they say nearest cents, that is 2 decimal places. All right, y'all, so let me see. When I did that, I ended up with, rounding it 2 decimal places, $8,193.08. Now, don't put the money symbol in. MathLab will put that in. All you're putting in is the amount. MathLab will already have that little money symbol on the outside of the answer blank, okay? All right, y'all, number 10, find the logarithm. They're giving me log base 10 of 0.01. Now, remember, a log base 10 is still a common log. So a log base 10 can be used with the log on front of your calculator. So you can use the log that's by the 7, or if you want to punch it in like this looks, you can go to math and arrow down to log base. So you could go to math and then arrow down and get log base. But I will say this, since that's a decimal, y'all should get a negative answer on that. So y'all punch that in and find me a log of 0.01. Carney, what you got over there? -2. Good job. Y'all, that's what MathLab wants. So let me show you real quick on the calculator in case y'all forgot. So since it's a log base 10, I could have used this log right here by the 7 and then punched in a 0.01 and enter. Or you could have did the math and went down to the log base that way and hit enter. And on this one, you could have actually put in the 10 and then the 0.01 and enter. Either way, you're going to get a -2, okay? All right, y'all, number 11. Log base 5 of the cube root of a 5. So y'all will match like mine. Your bases will match. The only difference, your numbers might be different than my 5s, and y'all might have a different index for your radical. But y'all, what I would do to this is rewrite it. I would bring out that log base 5, and I'm going to rewrite this part right here as 5 to what exponent? Do y'all remember how I rewrote these radicals? And y'all, I'll give y'all a clue. It'll be a 1 over something. 1 over 3, perfect. So the radicals, if you got a 5 here, you'll have a 1/5. If you got a 7 here, it'll be a 1/7, and so on, okay? So here's my question. You got a log base 5 of that base raised to an exponent. What will that equal? Angela, good job. That equals the exponent, which is the 1/3. So remember, if the base matches the base raised to an exponent, the answer will always be the exponent. And y'all, if you want to, you could have did the log base like this, put in your 5, and then put in 5 to the 1/3, and you'd have got, it probably gave you a decimal, but then you turn it back into a fraction, okay? All right, y'all, moving on. That's what, number 12? All right, number 12, we're going to convert to logarithmic. So they're going to give you an exponential. They're giving me q to the m equals 36. So if I'm going to convert this to logarithmic, I need to write log. The base of my log is the same as the base of the exponential. So you're going to have a little q sitting here. The result is a 36, and that's going to equal the exponent of m. Okay, so this right here is what MathLab is going to want. So 13 is going to go the other way. On 13, you're going to convert to exponential. So y'all, let me see what they're giving me. They're giving me a log 0.0001 equals -4. Okay. So here's my question on this. I need to figure out what the base is so I can convert it to exponential. Well, there's not a base shown, so what is my base? 10, good job. So you got a 10. Remember, if there's not a number down here for the base, it's 10. Your exponent is -4, and that's going to equal to 0.0001. All right, y'all, then we got to 14. It says use a calculator. And you're going to estimate this 4 decimal places. And y'all, they're giving me a log of 4. So you can push that right on the front of your calculator. So let's go do that. Let me clear everything. There's my log button. So punch log, put in 4. We're going to round it 4 decimal places. So y'all, that's going to be a 0.602. All right, so my fourth number to 0 has a 5 after it. So I'm going to turn the 0 into a 1. So I get a 0.6021. All right, now 15 says find the log using change of base. But for us, that means the log base. So you're going to hit math, arrow down to log base, and punch this one in. So this one is a log base 800 of 90. All right, y'all, so let me go to that calculator and let's punch that one in. So for that one, like I said, we physically got to go to the log base. So I'm going to hit math and arrow down, hit enter. So I had my base was 800, and then my result was 90. Now, rounded off 4 decimal places, when we hit enter, I'm getting a 0.673. Oh, and y'all, once again, my fourth number is a 1. It's got a 5 after it, so I'm going to turn that 1 into a 2. So I'm going to get a 0.6732. All right, let's see. 16. Express as a product. So this was when we started getting into 9.5 and I were doing those properties of logarithms. So this one has a log base m of t to the 17th. And y'all, anytime they say express as a product, all you're doing is taking that exponent and bringing it down to the front. So whatever your exponent is, bring it down to the front, and you can rewrite this as 17 times log base m of your t. Okay, so that's all y'all are doing on that one, bringing the exponent down. Now 17 is a little more detailed. 17 they want to rewrite as sums or differences. All right, on 17, I got an ln of x to the fourth, y to the sixth times a z. So here's my first question. This is a product here. So when I rewrite the product, will I rewrite it as sums or will I rewrite it as differences? What would y'all do? And y'all, that would go back to the product rule for your logarithms. All right, so here's the thing. Since these are being multiplied, we will rewrite it as sums. Now distribute the ln to every factor. So I got an ln of x to the fourth plus ln of y to the sixth plus the ln of my z. Now there is one more thing I got to do to that. I've got my sums, but there's still one more thing I got to do to that.
Don't you have to bring forward your exponents?
I got to bring those exponents down. Good job. So I got two exponents that's got to come down in front, sort of like what we did right here, right? So you'll get your 4 ln of x plus your 6 ln of y, and then the ln of z stays the same. All right, so that's what MATLAB's going to want right there, okay? And y'all remember, those are LNs. It's not a capital I. It's a little L and a little N, okay? All right, y'all, 18. Let's see what 18 has for us. 18 says express as a single log. And if possible, simplify. So I'm pretty sure since they're saying that, if possible, simplify, this one is going to probably simplify a little further, okay? So y'all, let me break out 18. I got a log of 10,000 minus a log of 10. So here's my first question. These are being subtracted. Would I write them as a product or a quotient? Good job. It's going to be a quotient. Because remember, these ones being added were the products right here. So these are being subtracted. So you're going to have that log. The top will be the 10,000. And then since the 10 is being subtracted, it goes to the bottom. All right, so figure out what 10,000 divided by 10 will give us. So let's see, if I divide 10,000 by 10, that leaves me what, 1,000? So the first answer MATLAB wants is a log of 1,000. But y'all, this one does simplify. So what does a log of 1,000 give us? So someone punch that up on that calculator. And actually on that, y'all can use a
Three.
log. Oh, what did I just hear?
3.
3, perfect. Good job. So you got to put it, your single log here, your quotient, which divided into the 1,000. Then you got to take the log of the 1,000 and simplify that to a 3. So MATLAB wants both of those simplified, okay?
So will we do the scrap work like this for number 18?
Um, that was one of my numbers there.
Yeah.
Yeah, so you can either, yeah, I'll take anything on that one.
Okay.
I'm good. All righty, y'all. So what's that give us? 19. Oh, let me shoot that back up so we can see that. All right, 19 says simplify the expression. And they're giving me a ln of x squared plus 14x plus 45 minus the ln of x plus 9. Alrighty, so first thing I would do to this is write it as a single log. And since these are being subtracted, it's going to look like a quotient. So bring out your ln. The top will be the x squared plus 14x plus 45. On the bottom will be the x plus 9. Now, y'all, this is the one where you have to factor the top and try to see if you can find a factor that might cancel with that x plus 9. So we're going to factor that top. Now, we can't factor the x plus 9, so that's just going to stay x plus 9 on the bottom. But here's my question. X squared is an x and an x. Since that 45 is positive, both of my factors will be positive like the middle number. So can you find me factors of 45 that'll add to equal 14? And that's the whole gist of getting this problem right.
Is it 9 and 5?
It's a 9 and 5, perfect. Oh, well, look what happens now, Brandon. That x plus 9s are going to cancel. So, y'all, our final answer will be ln of x plus 5. And the x plus 5 has to stay in those parentheses. But, y'all, this one's an A, B, C, D choice on this one. And it has the answer perfectly like we got it, okay? All right, y'all. Number 20. Solve for x. They're giving me 5 to the 8x minus 3 equals 25. So y'all, on these exponential equations, my first job was to try to write both sides with the same base. Can you rewrite 25 using a base of a 5? So some of y'all looks like y'all are shaking yes on that. Yeah, I can rewrite 25 as 5 squared, right? So I get 5 to the 8x minus 3 equals 5 squared. So that's your first, you always want to start out trying to rewrite these ones as the same base. Well, y'all look at that. These bases match. And remember, we said if these bases match, then that means the exponents have to be equal. So this 8x minus 3 has to equal that exponent of a 2. All right, so now all we're doing is solving for x. So what, we're going to add 3 first. All right, that cancels. I get an 8x equals 2 plus 3 is 5. And y'all think what? Divide by 8 on both sides now? Well, that cancels, giving us our 1x. And, well, y'all, I can't do nothing to that, so that's just going to stay at 5 over 8. That makes sense. If you put that 5 over 8 up here in for that x, the h would cancel. 5 minus 3 would give me 2. And 5 squared is 25, okay? Now, you know they gave me one I could rewrite, so you know they're going to give me one that I can't rewrite, right? And y'all, here it goes. e to the negative 0.95 t equals 0.99. Y'all check it out. I'm not even going to try to rewrite this one with the same basis. There ain't no way I can rewrite a 0.99 as the e. So, since I cannot rewrite it, I'm going to take an ln of both sides. I'm going to do the ln of e to the negative 0.95 t is going to equal to ln of 0.99. Now, the reason I chose ln instead of a log on this one is because of that e. Now, remember, ln really is a log base e. So I'm wondering what I'm going to get on this left side. Since this is ln is a log base e of e to that exponent, what's my left side going to equal? Because don't that log base match that e? So since they're equal, remember, we said that this left side is only going to equal the negative 0.95 t. That's going to equal the ln of the 0.99. And y'all, the reason this only equaled that, remember, that ln of e is like this. So you had a base that matched the base raised to an exponent. It equals the exponent on that side, okay? So that's why I did that. So I got one more step, and that's to divide both sides by that negative 0.95. All right, so that cancels. All that's left over there is my t. All right, since this is a logarithm, we need to round this out 4 decimal places. So for that one, I'm going to my calculator. I'm going to clear all that. All right, so on top, I'm going to make this look like a fraction by hitting the alpha y equals and enter. On top is a ln 0.99. I'm going to close that and arrow down to the bottom, which was a negative 0.95. All right, y'all, let's round this out 4 decimal places. So that's going to be a 0.010. All right, the 5's in the 4th spot, but look at that, it's got a 7 after it. So I'm going to make that a 0.0106. All right, y'all, that would round me out, what, 4 decimal places like I need? Okay, so 0.0106 on that one. All righty, y'all, so that's up to 21. So now they're going to get into the logarithmic equation starting on 22. So I think they're going to give me 2 logarithmic, and then we'll do the 9.7 stuff, okay? So for 22, solve for x. They're giving me a log of x equals -1.
Can you really quickly go back to question 21? I'm sorry.
What was it, 21? Uh-huh.
Okay, thank you.
Okay, no problem. And y'all, on this one, I got a single log equal to a number. So this is when I rewrote these ones as exponential. And once again, you got to remember, since there's not a base here, that base is a 10. So I'm getting 10 to the exponent -1 equals x. Now think this and let me try something real quick. Oh, yeah, also that one you can do on your calculator. So I had what, 10 to the -1. So let me clear this out. So here we go. 10 exponent -1. When I hit enter, is going to give me a 0.1. So if you had a 10 -2, you'd get a 0.01. A 10 -3, 0.001, and so forth, okay? All right, let's see. 23 is solve the equation. All right, so let's see what they got us here. They got us a log base 7 of x equals 1 minus log base 7 of x minus 6. All right, y'all. So for our number 23 here, I got a log on this side, but I got a number and a log on this side. So my first step would be to get all the logs on one side. So I'm going to subtract the log 7 of the x minus 6 from both sides so that I can get all my logs on one side, okay? So I'm going to add a log 7 x minus 6 to both sides. Okay, so what's going to happen is on this side, I'll have my log 7 of x plus my log 7 x minus 6. And so since these cancel, all that's left on the right side is a 1. Now, you got two logs on this side, so at this point, we want to write this as a single log. And y'all, since they're being added, I'll write this as a product. So I'm going to have my log base 7 of x times x minus 6. All that is going to equal 1. And y'all, if you remember when I did these, I actually multiplied out that product. So I'm going to have my log base 7. X times x is an x squared. X times -6 is a -6x. All equal to my 1. Now, y'all remember, single log equal to a number, the same thing we had here, single log equal to a number. I'm going to rewrite it as exponential. So this one does have a base of 7. The exponent is the 1. And 7 to the first has to equal x squared minus 6x. So y'all look here, these are quadratic. Remember, when they were quadratic, I got everything on one side equal to 0. So to do that, I'm going to subtract 7 from both sides so that I get 0 equals x squared minus 6x minus that 7. All right, so to solve this, I'm going to factor it, but this is where y'all were using the, if you wanted to, you could use that quadratic formula web page that was in, I think it was in week 5, where that was available. I know it's in the second test module stuff, okay? I'm actually going to factor it. So x squared is an x and an x. The last number is negative. Anytime the last number is negative, you had unlike signs. and you found factors of 7 that'll subtract and give me a 6. So, y'all, what factors of...
71.
Okay. Ooh, that was quick. Just remember, the larger number has to be negative like the middle, so make that 7 negative and that 1 positive. All right, so now you got it factored. Set both of those equal to 0 and solve it. So y'all here, I'm going to get what, a -1. And on this one, I would add 7 and get a +7. All right, so y'all, the question of the day, what are we putting in MathLab as our final answer?
The 7 because it can't have a negative number.
Oh, perfect.
Yeah.
Scratch out that negative one, y'all. Good job. And the only answer is our +7. Yeah, so that was tricky. Just remember on 23, once you get them, you're always going to have a negative on this one because it's going to give you one answer negative and one positive. Keep that positive answer only. All right, y'all, let me see. 24 and 25 are doing the new stuff with the exponential growth that I did the other day. So for mine, in 2012, population of a city was 5.02 million. Exponential growth rate, so the growth rate was 1.56% per year. So for A, they want me to find the exponential growth function. Now remember, since we're dealing with exponential growth, these were continuous compounding. So for those, I used a different formula. I used a formula that was P of T equaled my P initial times E to the KT. Okay? So when they want you to find the exponential growth function, you're basically filling in your formula. Now, MathLab will give you the P of T. We got to fill out the right side. So my initial population was 5.02. Now it's understood to be in millions on this, okay? But we don't have to actually write that million. So we got 5.02 times E. All right, K is my growth rate. But y'all, you're not putting in 1.5%, 1.56%. What are you putting in for RK on that? All right, y'all. So remember on this one, you're definitely moving that decimal left twice, remember, to go from percent to decimal. So if you go left twice, you're going to get a 0.0156. So put in your 0.0156, and then that'll be times T for time. So I can use this formula to find the population at any time T, okay? Now, this is what MathLab is going to want. Now, part B, estimate the population in, the year is 2018. So what we got to figure out is how many years is 2018 from 2012. And let's see, what is that? 2018. If I subtract 2012, I get perfect answer. That'll be 6 years. So since it's 6 years after 2012, I'm going to find the population in 6 years. That'll equal 5.02 times e to the 0.0156 times 6 years. Now let me see on this one. I'm going to round it 1 decimal place. So y'all on that, when I punched that in, I ended up with a 5.5. Now, all you're going to do is put in the 5.5. MathLab will already have the million there, okay? Now for part C, it says the population will be 9 million in about blank years after 2012. So we don't know how many years it's going to take it to be 9 million. So this is where I gave you the formula T equaled the ln of your PT divided by P original all over your K. All right, y'all. So it's going to be the ln. Well, PT is the ending amount, which will be your 9 million, divided by your original amount of 5.02. All of that divided by K, which is 0.0156. So y'all, let me show y'all how I would punch that one in on my calculator. And on this one, I'm going to round it 1 decimal place again, okay? So this one's a little trickier to punch in. So let me clear everything off. So I would hit alpha y equals for my fraction first. Now on top, I would hit ln. And then I'm going to do the alpha y equals for the fraction again. And then on this, I'll put 9 on top, arrow down to the bottom, and put in 5.02. All right, arrow out of that. I'm going to close those parentheses. And then I'll arrow down to the bottom and put in a 0.0156. All right, so let's see how many years after 2012 this population would reach 9 million. So y'all, I'm going to hit enter. And remember, I'm rounding it 1 decimal place. So y'all, that looks like what, a 37.4. Since the 4 has a 2 after it, I'm going to leave that a 4. All right, so about 37 years after 2012. So that'd be like the year 49, I guess. Okay, so you're with me, Ella, on that. I got that from that 9 million, okay? All right, let's see. D, I think they want to know the doubling time is about blank years. Well, this went to 9 million, which wasn't half double yet. It took it 37 years. So the doubling time better be a little bit more than, I would say, the 37 years, right? So I gave you a formula. Double time equaled the ln of 2 divided by k. So we're going to take the ln of 2 and divide that by our k, which is 0.0156. Now, y'all, double time, they want me to go 1 decimal place. All right, y'all, so let's go back to the calculator. I'm going to make it look like a fraction again. So I'm going to do the alpha y equals and enter. On top, I got an ln of 2. On bottom, 0.0156. When we hit enter, I'm going one decimal place, so it looks like this will be 44.4, which was more than my 37.4 that I got on number C, okay? So I knew it'd be more because double would be like 10 point, well, that'd be about 11 million. So a couple more million had to be about, about 7 more years on that one? Okay. Whew, all right, so I'll let y'all write that one and we'll knock out the number 25, our last one. And y'all, 25 is similar, but it's dealing with money this time, okay?
Can I ask a really random question? Does Math Lab require you to put the commas or no?
Um, okay, so what commas are you meaning?
I was just looking at the next problem. That's all.
Okay.
So like in the bigger numbers, does it require you to put a comma or do you not have to put a comma?
I mean, you could probably get away with doing 12225, which is mine's value. Um, hmm. If you didn't put commas, I don't think it would mark you wrong, but if it did, I could override that, okay? I'm used to putting commas in mine, but I don't think you got to technically, okay? So let's see. So on mine, they're investing 12,225 is invested, and mine is 6.3% per year, compounded continuously. Now, since it's compounded continuously, we're going to use the formulas like we just did for the P of T. So for my A, they want me to find the exponential growth function. So that's going to be your formula, okay? So they're going to have the P of T for you, and we just put in the formula. So right here, if this is what you're talking about, Ella, you could probably do like this, 12, 2, 25. They'd probably keep that as correct, okay? But if you want to put a comma, you can throw that comma right there. All right, then I got my E. I need my K, which is my interest rate. 6.3. You're going to move that decimal left twice. So that's going to give us a 0.063 times T. Okay, y'all, so that's the biggest thing is to turn your percents into decimals. Okay? So y'all, this is what MathLab is going to want for that answer. Now, part B, they want to know the balance after T equals 1, 2, 5, and 10 years. Now remember, y'all can punch in this formula, put a 1 in for T, punch it in to see what you get. And now these we're going to round 2 decimal places. But y'all, I'm going to show you what I did on this. What I do is I graph this function. Because by graphing it, I can go to my table and I can get all these values really quick. Okay, so either that or punch them in individually on front by putting a 1 here, a 2, then a 5, and then a 10, okay? But I like to graph them because I can graph the function once and get all 4 of my answers. So I'm going to go to y equals, clear everything off. I'm going to put in my function, which was 12,225. Now, see, I don't use commas here, so I'm pretty sure MATLAB will take it without commas, okay? I want to hit second ln to get the e with the x. And up here, I'm putting in 0.063. Now, instead of t, when you're graphing, instead of t, you got to use the x, okay? But there's my formula. So let me go to second graph for my table. And I'm on 4, so let me go up to, what was first? 1. Now at 1, you see it's only giving me 13,020. But if you'll highlight that y value, down below in the bar now shows 13,019.95. So that's what I put at 1 year, 13,019.95. Then I go down to 2 years. So I'm going to go down to 2 years. If I look in the bar, I got 13,866 point. Oh, y'all look at that. 599 is going to round up to a 0.60. Because right, that first 9 will be a 0, which turns the 5 into a 6. All right, then I'll go down to 5 years. So at 5 years here, I'm at 16,751.42. And then finally, let me go down to 10 years. So that's 7, 8, 9, 10. At 10 years, I got 22,953 point. So 7, 8, 8 got a 9 after it. So I'll make that a 7, 9. And the main thing to realize is that your money better be going up every year, okay? So your values got to get larger and larger as you go. All right, y'all. Then finally, it wants the doubling time. So since it wants the doubling time, once again, I'm going to use my formula. T equals the ln of 2 divided by k. So y'all, that'll be the ln of 2. What was my k? My k was 0.063. All right, y'all. So one of y'all punch that in for me real quick and see what y'all get for the doubling time. And that we're going to round it 1 decimal place. And let's see. I know this. At 10 years, I'm not quite double because double would be like 24,450. So it's got to be a little bit more than 10 years. So y'all, let's push that in and see what we get. I'm going to go back to the front, and I'm going to do an ln of 2 divided by 0.063. Tiffany, I think y'all are right. You and Brandon, I think, are right. And I get 11.0. So just remember, they want you to round that 1 decimal place. So make that 11.0, okay? So that MATLAB's real picky, so y'all need to add that 0.0 and y'all be good to go. All right, y'all. That is Module 4 test. Now, a lot of y'all have been sending me my bonus in. But y'all remember, the bonus is worth 2 questions on this test. So since there's 25 questions, that'll be 4 points each. So if you send that bonus back, that is worth 8 points on this one, okay? So you could technically get good grades on this one test. Y'all, that's it, right? 25 questions. So, any questions on that? And y'all just follow the